Now, let's start studying the response of systems under the influence of external forces. I will start with undamped systems, and we'll start with simple harmonic forcing. Now, for a simple undamped system, a mass spring system, the equation of motion is mx double dot plus kx equals f of t. You can derive this simply using Newtonian approach or energy approach. It's very straightforward. Now, let's assume that we have a harmonic force, that f of t is a harmonic force in the form f of t equals some amplitude f0 cosine, and the frequency of excitation is omega. Now, let's substitute this force into the equation of motion, mx double dot plus kx equals f0 cosine omega t, and let me normalize with respect to the mass, divide by m. X double dot plus k over m is omega n squared x equals lowercase f0 cosine omega t, where f0 is f divided by m, and this is called mass normalized force. Now, this is a non-homogeneous linear differential equation. It has two parts for its solution. We have a homogeneous solution, x homogeneous, and we have a particular solution that will constitute the total solution of this differential equation. The homogeneous solution in vibration, we call it the natural response, and the particular solution, because it's a solution that is associated with the right hand side, and the right hand side is basically the forcing term, so this will be known as the forced response. Now, to solve this differential equation, you have to go into two steps. First, solve the homogeneous part to get the homogeneous solution or the natural response, and we've done that in the previous lectures. Now, I need to find the forced response. The forced response, I will have will use the method of undetermined coefficients. I will assume a solution x particular in the same form of the excitation term. I assume that xp is some amplitude unknown, undetermined, cosine, and the same function omega t. And then I will substitute this assumed solution into the equation of motion. So I will get the second, well, actually substituted to this equation of motion. The second derivative is negative omega squared x cosine omega t plus omega n squared, and the x itself, x cosine omega t, that's equal to f0 cosine omega t. And now from this equation I can solve for x. I can cross out the factor of the cosine omega t term, and solving for x, I will get x equal f0 divided by omega n squared minus omega squared. So now that means that the forced response this is the forced response amplitude, and xb is f0 divided by omega n squared minus omega squared cosine omega t. Now, the total response is the sum of both the homogeneous and particular solution, or the natural and the forced responses. So x of t in total, we already determined the natural response of the undamped system, which was a cosine omega n t plus b sine omega n t, that's the natural part, plus the forced part, the particular solution, f0 divided by omega squared, omega n squared minus omega squared cosine omega t. And we have to differentiate here between omega and omega n. Omega n is the natural frequency, and omega is the frequency of the excitation force F. Now, A and B, we already determined what A and B are for any given initial conditions. But really we cannot use the values we determined previously in the natural response, because to determine now the parameters or the coefficients A and B in the total solution, I have to substitute the initial conditions in the total response before determining A and B. So I will have to use the derivative x of t, x dot of t of this response, which is negative omega n a sine omega n t plus omega n b cosine omega n t minus omega f0 divided by omega n squared minus omega squared sine omega t. Now I will use my initial conditions I used before. x0 is x0 and x dot at 0 is v0. Substitute into these two equations. Okay. For x0, I will have x0 equals cosine 0 is 1, so that would be a, sine 0 is 0, plus cosine 0 is 1, that would be plus f0 divided by omega n squared minus omega squared, and this will x0 minus f0 divided by omega n squared minus omega squared. And for the second initial conditions, v0 is sine of 0 is 0, sine of 0 is 0, cosine of 0 is 1, so I will have omega n b which means that b is v0 divided by omega n. And that's the total response of a simple undamped system under the effect of harmonic force.